Welcome to this explainer. Today we're taking something that feels incredibly futuristic, maybe even a little bit like pure magic, and we're going to break it down into a clear, understandable process of math and engineering. If you've ever wondered what is literally going on inside the glowing brain of artificial intelligence, well, you're in exactly the right place. We are going to demystify how ChatGPT works from the ground up. Okay, let's dive into this. To really grasp the mechanics of generative AI, we first have to answer a pretty foundational question. What is the fundamental difference between a traditional Google search and ChatGPT? I mean, we use both of these systems every single day, right? But behind the screen, they're executing two completely different tasks.
Think about Google's search for a second. You can basically picture Google as a giant, impeccably organized digital library. When you type in a question, it searches its massive index to find an existing website that already holds your answer. But ChatGPT, it operates in a totally different way. It's essentially a giant artificial brain that predicts words. It doesn't look up websites or retrieve pre-written files. Instead, it mathematically calculates and generates brand new sentences entirely on the fly, just one word at a time.
Section 1. The AI Training Factory. Long before you ever type a single prompt into ChatGPT, a massive amount of preparation has to happen behind the scenes. And the scale of this training data is absolutely staggering. We are talking about millions of books, the entire Wikipedia, complex scientific papers, millions of lines of programming code, and endless internet conversations. Imagine all of this human knowledge acting as raw material. Inside the AI training factory, all of these documents are effectively dissolved into billions of digital particles. The system takes this vast ocean of human language and compresses it into a neural network. It's basically an assembly line of information operating on a truly cinematic scale. But how does a computer actually digest all of that text? Well, the AI doesn't read like you or I do. If you feed it this sentence, "I love artificial intelligence," it doesn't read the whole thought at once. Instead, it uses a process called tokenization. It breaks the sentence down into tiny, glowing digital cubes, which we call tokens. It chops up the sentence into individual pieces, "I love artificial intelligence," and then it actually converts each of those tokens into pure math. Words become numbers, simply because numbers are the only language the AI truly speaks. So how does the AI build actual meaning out of just numbers? Well, it happens through a fascinating process called embeddings. Now, what's really interesting about this slide is imagining a massive 3D mathematical galaxy. In this space, words float around kind of like stars. Words with similar meanings, like cat, dog, tiger, and lion, they cluster tightly together in one neighborhood. Meanwhile, words like plane, car, and rocket form a completely different cluster far away. This spatial mathematical distance is exactly how the AI understands the relationships and meanings between different concepts.
Section 2. Inside the transformer.
Back in 2017, researchers introduced a revolutionary architecture called the transformer. And let me tell you, it completely changed AI forever. Before this, AI models read text sequentially, yet one word at a time, reading left to right. But the transformer architecture does something incredible. It examines every single word in a sentence simultaneously. This parallel processing allows the AI to instantly look at the entire context of a paragraph in just a fraction of a second. The secret sauce making this all possible is a mechanism called self-attention. Self-attention measures the mathematical relationships between every single word to figure out context and importance. So the AI isn't just randomly guessing. It assigns specific mathematical attention scores to figure out exactly who is doing what and to whom. Think about this micro-narrative for a second. The animal didn't cross the road because it was tired. Now, for a human, it's totally obvious that the word "it" refers to the animal. But for a machine, that kind of ambiguity is really tough. Through self-attention, the transformer draws these invisible mathematical lines of probability between all the words, connecting the word "it" strongly and specifically right back to the word "animal."
And it doesn't just do this once either. The AI utilizes what we call multi-head attention layers. Imagine 6 holographic brains seamlessly merging into one unified understanding. While Layer 1 is busy analyzing the grammar, Layer 2 is looking at the overall meaning, Layer 3 is tracking pronouns, and Layer 4 is mapping the broader context. All these specialized attention heads are working simultaneously to dissect the text. It's a real game changer.
To run all of these massive parallel calculations, you absolutely need serious hardware. A standard computer CPU would literally take decades to train a model this powerful. Instead, this process requires thousands of specialized GPUs, or graphics processing units, working in perfect tandem. These massive server farms are processing billions of artificial neurons simultaneously, sending electrical pulses of math through endless, incredibly complex layers of the network.
Section 3. Generating answers step by step.
Okay, so the factory has compressed the data, the language is mapped, and the transformer architecture is fully powered up. Let's say you submit the prompt, "What is gravity?" When the AI starts to speak, it doesn't regurgitate a stored paragraph. Instead, it relies on next token prediction. It actually calculates a probability distribution wheel for what the very next word should be. It might determine, say, there's an 85% chance the first word is gravity, a 10% chance for it, and a 5% chance for the. It selects the top choice, outputs it, and then instantly recalculates the entire probability wheel for the next word. It is literally predicting your answer, just one single token at a time. Because it's predicting words based on probability rather than checking a database of absolute facts, things can sometimes go wrong. This is what we call an AI hallucination, when an AI confidently generates incorrect information. It's vital to understand that the AI isn't maliciously lying to you because it doesn't actually know what a lie is. Think of it like a puzzle piece being forced into the wrong place. The system simply predicted a sequence of words that had a high mathematical probability of following each other, even if the resulting sentence is factually wrong in the real world. So the crucial point is that the AI has limits to what it can process at any given moment. This is defined by the context window, which is basically a digital workspace where the AI keeps track of your ongoing conversation. ChatGPT cannot remember everything you've ever said to it forever. As your conversation grows, older messages eventually fall outside of this frame and just fade into the distance. It can only calculate probabilities based on the tokens that are currently active inside this window. This brings us to a stark realization of what AI truly is. On one side, we have the human brain, driven by consciousness, rich emotions, and complex personal experiences. On the other side, we have the AI transformer, driven purely by pattern recognition, probability calculations, and mathematical vectors. While AI is incredibly accurate at mimicking language, it is just mathematics. It doesn't think, and it doesn't feel.
Section 4. The future of AI.
As this technology evolves at a breakneck pace across nearly every industry, I really want to leave you with this powerful thought. The future of AI isn't about replacing humans. It's about amplifying human intelligence. When you peel back all the layers, artificial intelligence isn't magic. It is an extraordinary combination of mathematics, engineering, and human curiosity. It's a tool designed to help us solve bigger problems, together. So the next time you watch a generative AI type out an answer, remember the billions of calculations happening behind the scenes and ask yourself, how will you use this tool to amplify your own